Hello again, internets. I'm playing around with my variable frequency drive. This is actually the second unit I received, so there's the one from the last video. And as you can see, there's a bunch of growth very close to my high voltage output terminals. These are the control terminals for the variable frequency drive. So I just sort of mocked up all the different connections I would use once it's mounted in this box and hooked to my mill. Just to make sure all the different functions work the way I expect them to. Sometimes the manual is a little ambiguous as to what terminals do and how you set things up. So I'll give a quick run through and then explain this cable. So right now I have an external start-stop switch. So that goes in one direction and then the other, and you flick it real fast. Spins down, spins back up, which that function alone is really nice. On the current single-phase motors, you have to turn the mill off, wait till it spins all the way down, and then turn it to reverse. If you quick flick from forward to reverse, it'll just keep running. It's sort of in a crappy sort of way. You know, it's sort of out of phase and sounds horrible, but it just keeps running. The next thing that I have hanging off of here is this external potentiometer, which if you watch the frequency display there and listen to the motor, sets the frequency of the drive. So I can mount this up on the panel. My plan is to get another one of these little multi-turn dials, and then you can actually just, have a little chart. So, this number on the dial is about this frequency, so you don't have to sit there and hunt and peck for the speed you want. The next thing is this meter here. There's one analog output which is meant to drive the meter, and it either can display frequency or current. I'm planning on putting a tachometer on the output spindles, so I don't really need frequency because it's the same thing. But current is interesting, because as you load the motor down, which I can't do with my hands and I'm not going to even try, the current will increase because it's drawing more power. So it's a sort of poor man's indicator of if you're overloading the mill. The other interesting thing I found out, it's totally counterintuitive, is as I go up in frequency, the current to the motor drops. And just to prove that the meter is not out of whack, this is the digital current reading. So right now the motor's drawing 1.1, 1.2 amps. And as I come back down, we're sitting at this sort of 3 amp range all the way down to the bottom. And if I go back to frequency, bring it up to 60 hertz, which is normal. Current's about 2.9. I did not expect that. I expected as you went up in frequency and you drive the motor faster to use about the same amount of current, if not more. Maybe the motors get more efficient at higher frequencies. I don't know. Someone on the internet can explain it. The last thing is this little button. So if you notice right now, let me speed this up so it's more dramatic. When I flipped off, it takes about 5 seconds to spin down, because that's what I have the motor set to right now. But this button, when it's engaged and I flip it off, it stops much, much faster. The plan is to hook this up in the EPO circuit, such that if I have an EPO event running along and I smash the button, it opens this switch to tell it to stop and closes this circuit to tell it stop really fast. The other thing this will come in handy for is I'm going to have a extra little dongle come out to a switch that I can position on the bed of the lathe. So when you're threading across, if you have a part and you're threading it, as you thread across, you hit that switch, it will turn off the motor and stop pretty fast. There's quite a few videos on the internet of people who've done this, and the threading will basically stop at almost the exact same point every time. That's one of the things that's always freaked me out about threading, is you always thread into the chuck. So if you don't hit the quick nut release or the half nut release fast enough, you ram right into your chuck, and you do something like that right there. So double use: 1, quick stop for EPO, and 2, threading stop. And it also does function after you send the stop. So I don't have to worry about sequencing the selection of the fast decel to the stop command coming into the inverter. So that's all the little accessories that I think I will ever use on here, with the exception of these 3 outputs. This is a relay. Well, you can see the relay right there. Dry contacts. I will be using the normally closed pair, or the common and the normally closed terminal, and it's set up as fault. So if either variable frequency drive takes a fault for whatever reason, over temp, internal self-test, whatever, this relay will open up, which will then interrupt my EPO circuit. Also, I added a fuse holder with a 10 amp fuse. This calls out like a 15 or a 20 amp fuse for inrush purposes, so I wanted to make sure it worked fine with a 10 amp fuse, which most of my reading says it would. And that also lets me use 10 amp contactors, which are much cheaper than a 20 amper. So the last thing I have to show off is this cable. My inverter came with software, and let me get out of the screen. So you fire it up, you hit COM setup, and you basically go auto. You tell it which port. So first off, cable comes from there and comes up to this little dongle. This is a USB to 485 converter. So you just need ground and the 2 signal pins. Pretty easy to hook up. Then you hit COM setup, tell it which COM port, auto scan, and poof, you're connected. You can see the drive, firmware version, and all the other various tidbits. So the bulk of what you do is in this quick setup. And you pick what you want your display to show: rated motor current, no load current, 2.8, your max frequency, which is out here, your motor rated frequency and voltage, which I forgot to change, 208, some upper bounds, lower bounds. But anyways, you basically just step through here and set up all the various bits. Stop, ramp to stop. Yep. All the various selections for your input, output terminals. And then hit OK. Say yes, and poof, your drive is all configured. You can also go to parameter setting, which is needed to do some of the more advanced stuff. So for example here, this AO signal I turned on, which tells it to, which is the analog meter. By default it's 0, which is frequency, and I set it to a 1. The other one I played with, I think, was under basic. Yep, basic. So here's the 5-second accel decel from the quick setup, and then I changed decel time 2 to ½ second. So that was about the only things I had to go into this advanced or the parameter view to set up in the drive controller. So another interesting thing you can do from this utility is trend and monitor. They both do about the same thing. They just display the data in a different way, and trend has a few more options to it. But if I bring up monitor here, hit start, then pick output frequency, output current, let's see what else, DC bus voltage, yeah, good enough. So set up a few different things and then go play with this end. you can actually remotely watch what the controller is doing in real time. And if I go exit, go trend, start that up. Trend is similar, you just got way more lines here that you can apply to the graph. But you sit here and play with it, and it sure shows the same stuff. This is a 2-way motor, yep. So you can make pretty pictures and debug various things using this. Let's see, exit. So the software is pretty straightforward and easy to use, and is a great benefit versus programming on the variable frequency drive itself. To program here, let me stop it. You have to sit there and go E, pick which category you want, hit E, pick which parameter you want, hit E, change the parameter. Oh, I didn't do it right. You know, and sit there and go through each parameter one at a time to set it up. And all the parameters are listed in the manual. So, much rather use that software than sit there and dink with each parameter one at a time through the interface here. That's about all I have for this video. I got one more thing I want to play with, which is why there's this blue tape on the motor. But I'll do that in a separate video before I go ahead and start mounting all that into this, and then eventually take that apart so I can install the new motor. Laters.